We are live from downtown Mill Bay. Oh. It just crashed. All of those problems were ones I just made up, and I've lost them all. Did the email make it through? Oh, please, please, please. Yes. And it couldn't because it's not here. Okay, I have a version of them. I will recreate the next one. This is super annoying. I'm so glad I made a little backup.
I'm gonna be sitting in a hot tub by in like 6 hours. No, you're the hotel we're staying at, I think has a pool. What? Let everyone know. Dude, Alex, are you actually gonna do that? I don't think you are.
Okay, first part of the problems on the board. Chatty people, sorry for the crash. You got an extra break. That was terrible. I can recreate them, but I have to take them out. So A is on. There is a B. Please do both. Bullet.
You're not needed. I'm not needed. Yeah, I'll read it. A cyclist jogs 200 meters, 25 seconds at a constant velocity. What is the cyclist velocity in meters per second? He went 200 meters, travels 200 meters in 25 seconds at a constant. Okay, 200 meters in 25 seconds. What? At a constant velocity. At a constant. Okay, so he's going. What is it? Okay, he's going 8 meters per second. 200 divided by 25. Okay, and then what else? 8. That's it. 2 0. Okay, the question is, what is the cyclist velocity in meters per 10,000? I know. There you go. The second one. If the cycle. Wait, man. He might be. Yeah, no. What the hell, man? Yeah. Okay. I just put the phone. Wait, no. Wait, question part 2. This needs to go. This one. Then we have 2 big accounts. So I didn't really have to do a problem with that. Wait, the loss. Okay, not that the meter. Yo, let me help. Alright, we're all going to we're all pushing the
Everything from B onwards is basically the same question, but I will let you know if you're on the right track, if you want to call me over in terms of answers. Hold it, what did I say? Oh, I can't spell a second. Oh, I lambasted the math teachers at lunch yesterday. Your final answers should not have fractions. What kind of nonsense is this? It should be a number with decimals. Because fractions don't exist. They're just a useful tool. It's not the final answer. That's the step before the final answer. You use fractions to figure stuff out, but they're not final answer. And that's because of something we'll do later called sig figs. Oh, you are so clever. You made the problem harder. I got the right answer.
Oh, we did?
Well, like, you know it slows down over 10 seconds. So you added 10 seconds and then minus 45, I got 10 seconds.
So you should have just wrote.
You could just write 10 seconds. But it was extremely clever. It was extremely clever. It will always be the answer to me.
This right here?
You can't have
Finishing Destruction is negative 8 meters per second.
Let me check.
Negative 0.8 meters per second.
What is that again? 8 divided by.
Okay. With a knot?
Why is this only 8 over 5?
Press S to
One
E.
consistent.
Is
Test.
5 seconds.
1.6. Okay, I was close.
Ooh, can I see? Yeah, that's good. And I was over 10 seconds.
Complete.
Oh, we got the wrong process. Point 8.
What's 8 divided by 5? Is it 0.4? Yeah. I think it's 0.4 though. It's the same thing. Or is it? Yeah, okay, that's fine.
Did I write it wrong here?
I was gonna say, I was.
1 second velocity in meters per second. And you got the correct velocity. Oh, 2.5.
What the hell is this? Okay, wait, we need to make it bigger. Oh, see, oh, yeah.
500 divided.
Stop, bro. Stop, bro. Stop.
10 seconds.
Oh, wait. It's because I used the wrong start.
Yeah, I think that 0 minus 25. That's the one. Yeah. What is? Yeah, there you go.
It's a new floorboard doctor.
We're done, sir.
Woo. We're just going to check A and B. I don't have the other ones, but they're going to be useful for a thing we're going to do in a second. Where's A? There. There's B. And where's the other ones? Excellent.
Okay, right, D, right, D, whoops.
A.
What is it? Acceleration.
B. B.
D, A equals.
There, good.
8
You
meters per
didn't check C,
second.
D.
I don't need to.
Oh.
You're going to use them in a second, but they should be getting progressively bigger.
Yeah.
Yeah, and the last one's like huge. Yeah. come back up, and I'm gonna get you to have a seat once you have it. Well done. I'm gonna take good, where's B? Excellent.
What'd you get for this?
You wanna check our word?
28, and perfect.
And there you
Point
go.
eight.
Did you
Eight.
Yeah.
Yes. Okay.
You made the bike.
Using your answer on the board, we're going to call people at random. I'm going to teach you a new formula that you don't need to know, but it's useful for you to know. You might have learned, should have, maybe learned it last year. I'm not sure, because I don't know what the grade 9 curriculum is. I'm going to go look it up since you didn't do physics and make sure you have everything and you're well prepared. The formula is F. I think I told you about it this last day. So we haven't discussed force at all. We probably won't discuss it a lot. But force is measured in newtons, and you already know what a newton is, because what is the unit of mass? Kilograms. And what's acceleration? That's energy. Meters per second squared. So a force is measured in newtons, and that is the force, and so you can measure the amount of force that you apply to things. And you'll notice the only thing that's missing from energy is another meter. It's not a joule is a kilogram meter squared per second squared. So if you take a force and you move it over a distance, you have energy. And that makes sense, because if I take a force and I move something over a distance that required a certain amount of force, that would have taken me a certain amount of energy. My muscles will literally have burned that amount of energy. We've calculated that all down. That would work. There's probably a little extra because of inefficiencies and anything else, but you can calculate it pretty close. Which is why things like people who say you have to have a certain diet in order to adjust your weight up or down or anything, and you have to eat only these foods. It's all nonsense. It's the laws of physics. You could eat donuts every day, and as long as you calculated the amount of energy and never ate more than that amount, you could lose weight theoretically. You would also totally ruin your body in terms of the lack of nutrients and other things. There's reasons we recommend good food, but it's just physics. So if this is energy and this is newtons, what did you notice about the force as you decrease the amount of time? It went up. And the reason I added this is probably maybe the most useful information that you will ever learn from this class, including all of the chemistry. So kilogram meter squared per second squared, that is equal to a newton. And we have force is equal to mass times acceleration. You have accelerations written on the boards for B, C, D, E. So for B, C, D, and E, I would like you to calculate the force for each one. You don't have the mass, so we need an average mass.
Is it a bike or a person?
Hold it.
What's it 10 kilograms? 10 kilograms? That's really it'd be 6.
No.
The person also weighs. Oh, the person who's riding the bike. It'd be 70 kilograms.
No, that's not right.
Or 70. That's average. No, 75 is average. How much kilograms?
The mass, we're going to go with 135 kilograms in each one. That is, if you want to do it for someone like you, just half that. That is, I'm just guessing. That'd be me. That is a large man. Okay, so all of these, I don't want to visualize yourselves because they're about to crash into a wall. So you could visualize me crashing into a wall, driving my bike at high speeds, and then deaccelerating. What is the force on my head in each case with this deceleration.
Oh, like the
Like calculate it. So you've got the mass and you have the acceleration.
What do you mean by force? Like inertia or?
No, this is the force. If you know when you slow down on a bike and you want to do this, it's because you are applying a force to slow down and your inertia wants to keep going.
Yeah.
So the amount of force on your body is that amount. And sometimes it's enough to throw you off your bike, or it's enough to break your bones.
So it is the inertia.
Yeah, it's the inertia. The mass doesn't want to change. We call it a deceleration, but it's just a negative acceleration. Calculate the force for all three. I'm not going to check the formulas. You can go get your numbers, and I'm going to ask a random 1, 2, 3, 4 people what the numbers are.
Second squared.
So, yep. What your deaccelerations are on the board for B, C, D, and E.
kg times meters.
Yep. Kg
Kilograms.
times meters per second squared. The acceleration. Kg times meters per second squared.
So it'll be a negative.
And so yeah, but you can ignore the sign. But yeah, it'll be a negative force.
Tyler, I need you to calculate some stuff.
I am going to give you what, a minute? Maddie, what's the reasonable amount of time to do those 4 calculations?
How much did you
A minute 30. Done.
135 times 135 by
Pardon? Needs to be negative. What we're not doing is directionality, which is something you get into later in physics. And so all negative means it's in the opposite direction you were. So the cyclist was going in a particular direction. Now there's a force going the other way.
You do it.
Yeah. Yeah. So like, if all of these was how long it took you to hit the wall. So if you slow down over what's the first one? 10 seconds? How long did it take you to slow down? No, that's the acceleration. 10 seconds, right? It doesn't break you out off the wall. You were slowing down for 10 seconds. Whereas the last one probably broke. Oh, that's time. Everybody done? Everybody done? Stop. What is Superman flying, or is that me? That's me. I've got a 6-pack. Oh. Excellent. So, E block. Isaac, what is the answer for B?
Read what we wrote on.
No, you have to tell me.
Yeah. Wait, Isaac. I'm not aware. Look at the book. Our answer.
Isaac, go read it. I called you.
Okay, wait.
While Isaac is reading it,
Alright, so the answer for number B
number B.
The bottom one.
is
Nope.
N equals.
Can't find it.
Did you?
In the answer.
Were you involved?
Oh, I was, yeah.
B,
108.
108.
Negative.
Negative 108 newtons, capital N.
Yeah.
C, I'm not going to rewrite all the things every time because this is an Y. App didn't like that. G, C,
200, negative 260.
negative 216. Half the amount of time, double the force. That makes sense. Jaden, D.
It's not here.
He's still, is he okay? Is his intestines need checking? I should go see.
Maybe.
Maybe.
Yeah, you should.
Aria,
Oh, there he is.
negative 1,080. And last one, Katie. $108,000 new. Gentlemen. So we go from, you might feel a slight force on your bike pushing you forward as you slide on the brakes. This was 10 seconds. What was that one again? See, how many seconds? 5 seconds. That was 1 second. And that was 0.01 or 0.01 seconds. So this is, you had to slow down, but comfortably and at a stop sign. This is maybe a car pulls out and you get that wrenching feeling like you might go off your bike at double the amount of force, but you can handle it. This is you crashed and you were wearing a helmet. All the helmet provides is a brief moment of time that allows time to happen before your brain stops. So it changes 0.01 seconds into like 0.8 second, 1.1 second. It depends how fast you're going. The faster you're going, the less that's still going to be, but it provides that gap of time. But you can see if you hit a brick wall and there's almost no time, the amount of force in you is tremendous. If you brake in a car and you do not hit your head, they now have a protocol for checking for concussion, because if you're hit, you don't have to hit your head. The speed at which you stop can be so sudden that your brain sloshes inside your head and you get concussions and internal bleeding from just from the stop. One of the students in my house, Tyler Van Keeken, who I adore, he was here. He didn't know why he was here because he had no plans to go to university. And his dad said, "You have to go to Brentwood." He says, "I don't want to go to Brentwood." He said, "Well, you have to." And so he came here. He wanted to work in a shop. We found a shop for him nearby, and he worked in there sometimes. He was relatively happy. What he did say is once he was here and he graduated, he said this did prepare him really well for tests and exams and learning things that he probably wouldn't have got into the school. He was happy because it turns out he didn't want to work in a shop. He wanted to rescue people, like on the Malahat, and drive the ambulance. And he's one of the people that will pick you up if you get in an accident. And some of the people that show up at the hospitals, they'll bring their friend in who's injured, and while they're treating their friend, they'll collapse. They were bleeding worse, but you can't tell because they weren't thrown around the car. They have no cuts. They have no bruises. They were going so fast that when they stopped, his heart vessels were a little weaker, and so his heart actually came out of place and ripped out, and so he's bleeding internally. So the amount of difference in terms of are you going to get to your destination on time, I am going to ask you to do another calculation. The highway speed on our highways, most of the time is 90 kilometers an hour. At 110, below that you get a certain fine. Above, I think, 20 kilometers an hour, the fine goes up. And then you get into like magic fine times. I had someone pass me the other day, and I think I clocked them at 160 just by, if someone goes by and you don't have like a speedometer or something, you can, if you know how far it is between 2 points, and you just time how long it gets there, then of course, as you know, you can calculate the speed. This is how they do it in airplanes. So they'll have an airplane above, and they have a white mark on the highway, and when a car passes this mark, they just start timing. When it hits that mark, they know the distance, they divide, they know your speed. They don't have to clock you, they just do it by the calculation. And then they radio up to the cop car, and he's like, you pull over. And you're like, I didn't see a cop car with a radar gun. Yeah, we don't need a radar gun, we just need someone to know math. Let's say you're doing those, and you have you're going on a journey. What's the distance between here? You're going to Victoria. Oh no, we're going to go to Nanaimo apparently because that's the fastest direction I can find. I have no internet. Does anybody else have internet? My internet in there wasn't working before, which is why Oh my goodness. It hates me. Measure distance. I'm not 500 meters from Nanaimo. Can someone get out their phone and measure the distance between here and Nanaimo? That's a reasonable trip you would make to go to the ferry. You want to reach the ferry on time.
It's like 69 kilometers.
69 kilometers? No, that can't be right.
69.5 or 72.
72 kilometers?
Yeah.
Oh, actually, no, that is reasonable. It takes about the new highway. Sorry, my brain was on old highway. So let's make it an even 70-kilometer
Hopefully subject to
trip. Time for let's say it's a nice even 70 to make your numbers nice. I would like you to calculate the amount of time in hours, so we don't have to do any weird calculations. And this will be a decimal, so if you get half an hour, 0.5, half an hour, then you know it's 30 minutes. For 1, 2, and 3, and given that this is actually a velocity formula we actually know, I should put you back in groups, because everybody really likes it when I do that. Excellent. Maddie, once again, you can join any group you want. Find your people. Go to the board.
Wilkinson. The truth will get over you.
It crashed again. You know what those numbers are. I'm going to rewrite them. It was 90, 110, 160, and 70 kilometers. I will rewrite it.
Ariel, will you mind borrowing
Yeah, erase everything else. Oh, your partners are here. Alex, you're with Aria. I think I have to restart my computer or something because something's going wrong.
He wants safe.
The time in hours. If as a bonus you're done and you're clever, convert to minutes.
Yeah, it's around 45. Give him like an S. How many decimal points? How many decimal points?
As long as you have at least like 3 numbers that aren't 0, that's fine.
Okay, so faster on time.
Oh yeah, time is 1 hour.
Yeah.
No, shit. Do you use the marker? No, I drew it down. Distance. Distance is 70.
Oh, so the velocity is, yeah. So you're trying to find the things above. Yeah. Maybe.
I know that. I wrote a dot.
It's repeat. So smart.
That's the answer?
No.
Well, that's all we have. So.
Yeah, okay, let's do 90. So this would be A.
No, but like that's rounding.
Yeah, this would be B.
See, I'm telling you. That's how far.
So it's 0.77. Okay.
I did all the things, so. What?
So now if you set the
Oh, no. What are you doing? What are you doing?
What have people gotten for the first answer?
I think it's 0.778.
0.778.
Wait, you round this up.
Oh. If you're very clever, convert to minutes. You are that clever. How many minutes in an hour?
That's 46 minutes.
That's 46 minutes. If you want 1 hour equals 40. Yeah, duh. 1 hour. How many minutes in an hour?
60.
60 minutes.
It's 47 around.
Every relationship that is a conversion, you can make into a fraction. You want to get rid of hours, so just like algebra, you put it at the bottom.
It's 47 minutes rounded.
You don't have to convert to minutes, but I am going to do it just so we can compare.
Oh yeah.
I'm going to ask someone now. No internet connection again. Sterling, decimal for number 2.
Oh yeah? He's a cutie. It's funny.
Sterling Ramsey.
Really? What's the second decimal?
Do you have the second one? B? What's B?
Second one? 0.64. No.
No.
HR.
Excellent.
Hour.
Hour. Or you're in trouble and you're going to HR. And job. 3. 0. How much? 438 hours. Now, did anybody convert those into minutes? What is this one in minutes?
36
36
and 26.
and 26. Okay, have a seat. go, let's go, let's go, quick.
No, it's good. There better be a pool at the hotel. Would be so close. Good work, man.
No, we saved.
I think that's how you say it.
I know, it's so difficult. Oh my god. Music. Oh yeah, what's your vibe?
If you are, gentlemen, if you are driving, one of the reasons the old advertising campaign when I was a kid in the 70s was speed kills, not for the drug, but for the speed on the highway. New cars, if you get into an accident, you can throw away the cars. If you've seen them, they just crumple completely. All of that is to build in that time to reduce the amount of force in your body. Old cars, like you get a nice, good 1950s solid steel car of any kind, and that crashes into the wall, that car actually often comes out pretty good. You just replace the bumper, maybe you have to straighten it a little bit. You have to throw away the driver because all the force went into them instead of the car. There's no crumpling zones. If you are going at 90 kilometers an hour, you will get there in 47 minutes. If you start speeding right up to the limit where the fine will really start going up, you only save about 11 minutes on a reasonably long trip. But if you start speeding at a tremendous speed, we now know how much force that speed will increase it by. You're only going to save 10 minutes from the previous one. You're now going, this was 90 to 110, so that's plus 20. But to save another 10 minutes on top of that, you would add 50 more just for the next 10 minutes. So as you get faster, there's actually diminishing returns. You don't actually get that much, but if you went up to another 20, you don't get another 10 minutes. So you don't actually need to speed to get there on time. Often it's just a matter of you've increased the risk to yourself and everybody else in the car. And because people can't do math very well, they think, well, if I just go faster, I'll half the time or something. No, you'd have to go double the speed. So if you're 90 and you want to get there in half the time, how fast do you have to go? 180, and like that's insane. You're going to hit somebody. Go to Germany, get on the Autobahn or something. Okay.
Yo, that's good, bro.
I feel like you were doing relatively well at those calculations. We should go back to the science 10. 9:14? When we walk back and forth a fair much, but I like doing a 5-minute break. You have until 9:20. The next section is set up. Yes. Oh, I'm gonna get so copyright struck from this if I don't shut things down.
Keep going.
Like that.
Keep looking left.